Hello everyone and welcome. Today, we're diving into a powerful analytical technique, high-resolution mass spectrometry, or HRMS, especially when it's paired with liquid chromatography. You might have heard the term, but what does high resolution really mean when we're talking about weighing molecules? Let's break it down in simple terms. First, let's remember what LCMS does. The LC part, liquid chromatography, is like a sorting system that separates the different molecules in a sample mixture. Then, the MS part, the mass spectrometer, acts like a very sensitive scale for those separated molecules, measuring their mass-to-charge ratio. Now, imagine you have two scales. One is a standard bathroom scale that only shows whole numbers, like 70 kilograms. The other is a hyper-precise scientific balance that can measure down to many decimal places, showing you a weight of 70.1234 kilograms. That's the core difference between standard mass spectrometry and high-resolution mass spectrometry. In MS, resolution isn't about picture quality, it's about the ability to distinguish between two molecules that have very, very similar masses. A standard, or low-resolution, mass spec might see two different molecules and just report a single, rounded mass, say, 28. An HRMS instrument, however, has much higher resolving power and can see the tiny differences. Let's use a classic example, carbon monoxide, CO, and nitrogen gas, N2. Both have a nominal mass of 28 when you add up the whole numbers of their atoms. A low-resolution instrument would just see a peak at mass 28 and couldn't tell them apart. But an HRMS instrument measures the exact mass. It would see carbon monoxide at its precise mass of 27.9949 and nitrogen gas at 28.0062. Because the HRMS can measure out to 4 or more decimal places with extreme accuracy, it can clearly separate these two signals and tell you exactly which molecule is which. This incredible precision is a game changer, giving us what we call high mass accuracy. This means the mass we measure is extremely close to the true theoretical mass of the molecule. This accuracy allows us to confidently determine a molecule's elemental formula. By knowing the exact mass, we can use software to calculate the most likely combination of atoms, like the exact number of carbons, hydrogens, and oxygens that make up our unknown compound. This is crucial in fields like drug discovery, food safety, and environmental analysis, where identifying unknown substances with certainty is vital. Common types of HRMS instruments you might hear about include time of flight, TOF, and Orbitrap analyzers. These are the technologies that make this level of precision possible. So, in short, using HRMS in your LCMS system is like upgrading from a blurry estimate to a crystal clear, definitive measurement for the molecular world. Thank you so much for watching. If you found this explanation helpful and want to learn more, please consider liking this video and subscribing to the channel. Your support helps me create more content like this. See you in the next video.